Stephanie recalled how this storyline romance morphed into an actual one.
Well, I mean, he got with her at one
Hello,
time.
guys. I'm gonna.
So by the time.
Okay, thank you. So we're gonna start. So we're gonna do today one more problem of substitution, and then we start trigonometric integrals. And tomorrow we will do more examples. Okay. So let me finish one example I wanted to do yesterday, so we can move to the new section. So we're gonna do the following. Let me check that this is recording. Yeah. Let me share my screen. So we're gonna solve one more exercise, and then we start doing some more integrals with trigonometry, but dealing more with the triangle, like more like with Pythagoras theorem and things like that. So the other example I wanted to do is this example. And is the integral of tangent to the 6 secant square x dx. Okay. So so here we can see, when we see this, we see a relationship. You see that you have secant square. Okay. Right. So we could try to do u equals tangent to see if it works. You know, if it doesn't work, well, then you try something else. And then du will be a secant square x dx. Okay. And I will show you in a second again the guidelines that the book gives you to try to deal with these integrals, and you'll have these guidelines in the exam. Okay. So let's try this one. Okay. So we have tangent, so it looks natural. Try u equals tangent, and the derivative of tangent is secant square. So that might look like it's gonna work. So we go here, and so we replace. So we got u equals tangent. So what do I get here in my substitution?
U to the 6.
U to the 6, and then what is 6 squared dx? du. Thank you, du. And now we replace, right? Let's put it here. So what is the antiderivative? Not replace, sorry. We integrate. So what is the derivative of u to the 6?
U to 7 over 7.
Over 7. And then let's not forget my plus c. I forgot my plus c. So let me put it here. But you know, you at the end you check, and you forgot the plus c. You write it there. And then plus c. And now, what is the last step? What do we do last? Because this integral is in terms of u, or the answer we are getting is in terms of u. So we need it in terms of x. So what can we do?
Plug in.
Plug in, yeah. So instead of u, I'm gonna write tangent of x, right? So my answer is tangent of x to the 7 divided by 7 plus c. Okay, and that's the answer. Okay, you can check it. How can you verify this? So you will have to find the derivative of this guy, and you should, as the derivative of that guy, you should get this one. Okay, so that's how can you check this is the right answer. Okay, so we can move to the next section. Now we're gonna do more exercises from tomorrow, but just to start your homework. Okay, you'll see you can do all of them. I was checking. I think you're ready to solve all of them. So we're gonna do the next section is called. So this one is called trigonometric integrals. The next one is trigonometric substitutions. Okay. So what is the difference between the two? So they're very similar, but let me make a new section here. Let's call it trigonometric substitutions. Trigonometric and I want to bring you hope. This section might be the hardest of the whole semester. Okay, so you have to be patient, but you will get it. Okay, but the first time you see it is probably the scariest. Okay, but then the fact that it's so specific, at the end, it make it the easiest, because once you see it, you see, okay, this has to be trigonometric substitution because it's so weird. Okay, so what kind of integrals we're gonna solve with this technique? So what kind of integrals can we solve with this technique? So at least in the last section, you see secants, tangents all over. So you like, okay, I had to play with substitutions, and I had to get some smart formula for trigonometry. Here, look at this. So this is the kind of integral you're gonna have. Like, for example, you could have a square root of 9 minus x squared over s squared dx. That will be one possibility, one example. Another kind is 1 over x squared right square of x squared minus 4 dx. So these integrals, they are so, you look at them and you're like, wow, that looks very difficult. Okay, so in that sense, that technique will be easy to figure out. So okay, this has to be this technique, and you just have to go for it. But the good news is there are identities, and the identities will tell you right away what substitution to use. In the last section, it's kind of difficult. The book tried to give you some guidelines, and I put it in the formulas for the exam. I like this table better because it shows you more like it review better all that it is. Okay, not many cases. You just have to look at it, and then you decide, okay, it has to be this substitution. And I just had to play. You have to be careful with each step, because you screw up with, if you instead of cosecant, right secant, or something like that, then the integral is totally impossible. So if something is not working out, it's maybe because you make a slightly mistake. Because these are so difficult that they are designed to work. Okay. So these are the formulas you need, and you're gonna have them in the exam. So first formula is, formulas you need. Formulas. I invite you to start writing them down so you memorize them. Okay, you need to get familiar with this. Okay, so the first one, you know it, 1 minus sine square of theta equals cosine square of theta. Yeah. Okay. So this is a formula, you know, right? But a good example, when are you gonna use that kind of integral in formula? But when you have that formula is associated to this kind of substitution: x equals a sine of theta. And for example, if you see in the integral something like a square root of a squared minus x squared, that's what you had to use. Okay. So, for example, in this example over here, that one. Okay. So, example, let's say B, let's say A. So, for example, A or B. So, which one do you think you use? Will you use this substitution for A or for B?
A.
A, because you have a squared minus x squared. This one is B is different. B is saying a square root of x squared minus 4, so that's different. Okay, so next one, the example could be something like this. With or without a square root, could look something like this. A square root of a squared plus x squared. So you see that one, you need to use this substitution. X equals a tangent of theta. Okay. So it's really those two columns that the ones that you need. This is just for completion. Like, why do I need this? Because in the process, you're going to use these formulas on the left. So the formula associated that you will use in your integration will be this one. 1 plus tangent squared of theta equals secant squared of theta. And the last one is x squared minus a squared. And here you use x equals a secant of theta. Okay. And the equation related is secant squared of theta minus 1 equals tangent squared of theta. Okay. So this is kind of the formulas that I'm going to make available for this section in the exam. So how are you going to use it? So let me give you an example here. So let's put here like philosophy. Right. This is the philosophy of the trick you're going to try to use. So suppose you have a square root of a squared minus x squared. So the idea is you want to cancel such an ugly term. Square roots of a sum or a difference are really difficult. So you make a substitution. So if we look here, let's call it 1. Let's call it 1, 2, and 3. So if you look at it, well, it's clear, right? We have to use 1, right? A squared minus square root of a squared minus x squared. So we need to use the substitution. We need to use the substitution x equals a sine of theta. Okay. So we're following this table. Okay. So now you're going to understand why. So when I replace in my equation, I get a square root of a squared minus a squared sine squared of theta. Right. Now I factor my a squared. So we have a square root of a squared 1 minus sine squared of theta. Now what do you think what I'm going to do? The idea is to simplify this to something nice. So what can I do here? Square root of a squared minus sine squared of theta. What could I do?
The 1 minus sine square can be cosine square.
Exactly. So you see, the problem gives me this. The problem gives me the square root, right? I make the substitution here, and then I make my I use my formula. So you have to use the 3 in a row. Okay? So the 3 are connected. So 1 minus sine square of theta is cosine square. So I get square root of a square cosine square of theta. Now, somebody's going to make me really happy here. So if somebody tells me, what is this? In your calculus 1. So let's see who had the best calculus 1 teacher. What is the square root of a square cosine square of theta?
A cosine of theta.
Almost. A cosine of theta, but not yet. What is missing? And remember when I was doing the integral of the absolute value, somebody asked me, what is the integral of the absolute value x minus 4, something like that we were doing.
Plus minus or something like that?
Yeah,
Plus
so,
or minus.
well, yeah, kind of, but really, this, remember, the definition of the absolute value is a square root of x squared. So this guy is the absolute value. So you will agree with me that you don't want the absolute value, right? So since you don't want the absolute value, we need to restrict the angle to be positive, okay? And look at this. So if we want the angle to be positive, so how is cosine? Cosine is like this. Cosine goes something like this and like this, right? And then goes all like that. So this is 0. This is pi halves. This is pi. This is 3 pi halves, and this is 2 pi. So I want cosine, the angle of cosine has to be, I want the function to be positive, so I don't want it to be negative. So I'm going to choose my angle between minus pi halves and pi halves. So this angle goes like this. So the angle, so my formula is not completed. This angle theta must be between minus pi halves and pi halves. So you need to complete your formula, but I didn't write it right away because I wanted to be able to explain where is this coming from. Similar thing for tangent. Tangent, if you do the similar argument, tangent has to be between minus pi halves and pi halves. Between minus pi halves and pi halves. And secant has to be between, the theta must be between 0 and pi halves, or pi and 3 pi halves. So people choose either way. So our integrals usually we will just find the angle between these, okay? But I want, when you see the formula, you're gonna see this. So I don't want you to be confused. So what is good is, like, once you replace this, so the answer of I don't know who answered my question. It was a cosine of theta. Is correct if theta is between minus pi halves and pi halves. Okay, so since theta is between pi halves and pi halves, I forget the absolute value and keep working. So it's already complicated. So we restrict ourselves to these angles to don't have to deal with absolute value. Okay. Okay, so now we have to use these famous integrals that we haven't using, that is part of our calculus 1, but they are not that popular, but now they're gonna be popular. So recall the following integrals. These integrals are gonna be important. The integral of tangent of x is ln of absolute value of secant of x. Let's see. This is in the table of formulas that I gave you already. The integral of cosecant squared, and they're not difficult. You can solve these integrals with substitution. Okay, is minus cotangent of x plus c.
Sir, can you go up a little bit? I have a question on the previous problem. Why is it that you get the square root of a squared minus a squared times sine squared? Why do you get 2a squared?
Over here?
Yes.
Oh, because I replace it. So I had x equals a sine of theta. So I replace x squared by this guy. It's my substitution.
Mm-hmm. Okay.
So x squared will be a squared sine squared, right?
Mm-hmm.
So you expand it. So remember, this is a property from algebra. So I have a sine theta squared. This goes like a squared times sine squared of theta.
Mm-hmm.
And this was x squared. So you take the square both sides and then distribute the square in multiplication. You can do it in multiplication, but you cannot do you cannot do it in when you add. So you cannot do a plus sine theta squared. This is not good. A squared plus sine squared of theta. That's not true. Okay, so this part is not true, but this is true. This is good. Is that a question? Or
Kind of. It's because it's the one to the side of that one right there. The a squared minus the a squared sine squared, and then that equals a squared to 1 minus sine squared.
oh, I factor a squared.
Yes.
Mm-hmm.
Okay.
Yeah, I factor a squared, and then that's what I can replace.
Okay.
Yeah.
Thank you.
Sure. Okay, so the other one we have is cosecant. Okay, so this one also, this will be weird to remember. So you probably you see this, probably you're gonna try to do your substitution, but you can just check your formulas to see you have it. Cosecant squared plus c. So the integral of cosecant times cotangent is minus cosecant x. So I just trying to write this down so I save you some time when you are doing those weird integrals. Integral of cotangent x equals ln of sine of x plus c. And integral of secant times tangent is secant of x plus c. And the last one, but again, these are just formulas, not that you have to memorize it. You will have it in your exam. I'm just trying to, provide them in case you don't follow the book or you don't think we're gonna use it. Yes, this can be saving you 5 minutes, at least 5 minutes in the exam, because you don't have to do it or more. Okay. Okay, so you don't have to worry about these ones because I given them to you. So you can just say in the exam by the formula provided, and then you write it down, okay? But you can just not give me any formula, okay? It has to be formulas I gave it to you. Okay, so let's start solving our first integral. I got this one from Wetwork. Let's see. Let's start from soft to hard, okay? So we're gonna do, let me show you here in Wetwork which problem I'm gonna do. So So we're here. So by the way, I'm planning to leave the exam for the 29, okay? So if you have special accommodations or you cannot take it, so there are going to be two options. But people taking this class at 2 p.m. has to take it at 2. For special reasons, can take it at 7. But people taking only the online class will take it at 7. I already have so many people at 7 that it's gonna be make it hard for me to proctor it. So I will have to give you another time. So it will be at 2 and at 7. So I'm gonna show you here the problem we're gonna solve. We're here.
Sir, is our quiz due tomorrow or on the 14th?
Let me see what quiz. Let me see what quiz I put. I think I think it says the 14th.
Okay, because you sent out an email saying that it was due tomorrow.
Oh, let me see. No, I put 2 problems. So no, it will be 14. I mean, I try to, but then I don't want to put more pressure on you. You have a lot of homework. But I will start doing this quiz as soon as possible, so you don't forget. I mean, ideally it's tomorrow, but I don't want to put more pressure. This topic, as I said, this topic is kind of scary for students. Any other topic is going to be easier than this. So that's why I move it to Monday. But usually I like it to be Friday, so we gotta we gotta schedule a routine. But this you're gonna feel kind of worried, so I don't want to put more stress on you. But so it's for Monday, okay? So we're gonna do here trigonometric substitutions. So this one is from these two are of the last section, not this section. This one, yeah, we can solve this one. Let's see if somebody has a. So integral of x over x4 plus 1. It doesn't have to use the hard. Okay, so for this one, you just need to use one of these integrals. So we're going to do integral example. Integral of x over x4 plus 1 dx. So let me give you 2 minutes. I mean, it's probably, I'm not expecting you to solve it, but if you do, you have a nice substitution here, that would be great, okay? But don't feel pressure. Try to do your best to see, write it down, integral of x over x4 plus 1 dx, to see what substitution you could use and in order to solve this. Let me give you 2 minutes, okay, to think about it. Exam on the 29th. I don't know if I said wrong. Exam is going to be on the 29th, not the 21st, the 29th. Because I'm going to finish the material this coming week. So next week we do partial fractions and integrals and infinity. And I always like to give a week. So I'm going to post a review, but I'm going to keep with the material. So the week from the 21st to the 25th, I'm going to keep with the next exam, with the topics of the next exam. But I like to give a week in case people, try to catch up and because this exam, I would like everybody try to do their best on this exam. So the exam is going to be on the 29th. Okay, I don't know if I said wrong, but I'll write it down on black.
Sir,
Yes.
you send because when you send an email saying it's going to be on the 21st of September, the exam 1.
Oh, okay. I see. Okay, sorry. So maybe I got confused with my other class. Sorry, I'm gonna fix it. So the 29, because I have 2 blackboards. So maybe I was doing it in a hurry and I did it wrong. Okay, so it's the 29. Thank you. I'm gonna change it right now.
For both class or just one of yours?
For both classes, both calculus 2.
Okay.
I have another class of differential equation.
Okay.
My differential equation is the 21. So you guys
Okay.
have the 29. So let me fix that.
Sir, when will you post the review for exam 1?
I can post it today. Sorry, I was on mute. Try to do this substitution. U equals x squared. So use this substitution, plug it in, and then try to give me the answer. Okay? Okay, so what do we do? So we go integral, and instead of, okay, what will be du? What will be du? Oh yeah, somebody give me an answer. So somebody said arctangent x plus c. Oh, arctangent x squared, yes. Somebody, Frank, I don't see his, Francisco Patiño. Yeah, good. So du will be 2x dx, right? So when I replace, instead of x to the 4 plus 1, what should I have? Instead of x 4 plus 1, what should I have? Instead of x to the 4, what should I have?
X over 2 squared plus 1.
Okay, so let me go slow on that. So u equals x squared. So since I need x to the 4, so if I take a square both sides on u, I'll get x to the 4. So instead of x4, I'll get u squared plus 1, right? But my substitution is u equals x squared. Now, I need to replace x dx. You see, I have x dx. So what I do is divide both sides by 2, and then I get du over 2 equals x dx. So instead of x dx, I write du over 2, and I can take that 1/2 outside. So I do 1/2 of integral of 1 over u squared plus 1 du. And now I want you to go to your table. Let me also go to my table. So go to your table, the table of the formulas for the exam that I have given to you. And let's use it. So tell me, what is that antiderivative? Let me put it here in announcements. I think the formulas, when in course materials is the formula. So these are my formulas for the exam. So what do you think? What is the antiderivative of 1 over a square? What is it? 1 over u squared plus 1. So you look at this and what do you tell me? What is the antiderivative of 1 over u squared plus 1?
1 over a tan 2 minus 1
Yeah.
sine x
Yeah,
over
this one.
a.
So yeah, let me fix you on something, guys. So you don't say this one really is not tangent to the minus 1 or tangent inverse. This is arctangent. Okay. So when you guys are and this is arc sine. Okay. So this is arc sine and this is arctangent. So this notation is kind of misleading, but we usually call it arctangent. So that's what we use over here. So it will be, this u is 1/2 arctangent of u plus c. But now what was u? U was x squared, right? U was x squared, so I had to replace it over here. So that's what I'm gonna do. I'm gonna do 1/2 arctangent. Instead of u, I write x squared, a squared plus c. Okay, so that's our first problem. That's from Wedbull. Okay, so let's do another one. And then I don't know, something in soon.
Sure, good question.
Yes, question.
Where did you get the two? Where did you get the x squared from? For the example right here for you.
Where is the what?
Where did you get the x squared for you?
Oh, because you see, I have x to the 4 plus 1.
Yeah.
So since I have on the bottom x to the 4 plus 1, I mean it's kind of really tricky. I'm teaching you so you can do it in the exam. I mean, it's highly probable. This is very tricky. I mean, I will ask it in the exam because I teach you how to do it. Okay, but yeah, I'm not expecting that is you do the u equals x squared, and then probably that's this is why, because on the top you have x dx. If you have x dx, you know that the u, this du, you make x squared, the du is gonna give you the x dx. So this factor x dx cannot tell you what substitution to use. So when you're looking at substitution, you need to see what is next to the dx, what possibilities you have. And now substitution not always works. But when it works, it's probably that's why, because you can see what is next to the dx. Okay.
Okay.
So let's do another one. But this is like you learn tricks, just like playing soccer. You know, you start. Somebody did this trick, and then everybody start doing the same. So let's do this trick. Another example. I'm building difficulty, okay? But in this integration, the ones that I show you here with this table, they might look ugly, but they're convenient because in a sense, you know what to do, right? So in the next one, let's see what you guys tell me what to do. So we're gonna do integral. This is also from webbook. Integral of 7x plus 5 over x squared plus 1 dx. So give me ideas. What do you guys would like to do before we get into the main plate? This is like you are warming up. We'll do the good one in a second. So you see the button, this one over here, that looks familiar, right? What is it looks like we can do the antiderivative of 1 over x squared plus 1. What is the derivative of 1 over x squared plus 1?
Is it 1/2 arctangent
Yes.
x squared?
Yes, so this is arctangent. Some combination of arctangent over here. It's just arctangent. The antiderivative of this one is arctangent. This is arctangent of x. Okay? So let's split this integral. How could we split this integral? And that will take me to the next week. This trick we're going to do now, we're going to try to do it next week a lot. Let's split this integral. How could I split this integral in two terms? Over here plus something else. What could be the first term?
7x over x squared plus 1 and plus 5 over x squared plus 1.
Yes, thank you. Why this is true? Because 5 plus 3 over 7 is the same as 5 over 7 plus 5 over 3. That's fraction. It's 3 over 7, sorry. 3 over 7. This is fractions, right? So you can do it with functions and you can do it with fractions. So this is true because we are adding. And also if you are multiplying, that's good too. Now, we are going to do, so Descartes or Descartes, I don't know how you call it, used to say, and that's what we do all the time in calculus, you take the big problem and split it in small pieces, and you start solving every piece at the time. So that's what we're going to do here. So we're going to start solving the first one, 7x over x squared plus 1 dx plus integral of 5 over x squared plus 1 dx. So so right now we are not face-to-face classes, right? But what I like to do in my face-to-face classes is, this will be a quiz, 10 minutes quiz. You have to find the integral of each of these two, because I believe you can do it right now. So let's take 3 minutes. So you solve me these two integrals independently. Okay? So that way I can verify your degree of understanding, okay? So try to solve both integrals in 2 minutes, or at least one. Choose your favorite integral, and you say, okay, this integral is easier, I'm gonna solve this integral. And then we will do solve together both. Okay, so the people that choose the first integral, so you're gonna help me. How do we solve the first integral? How do we solve this integral 7x over x squared plus 1? This is not even of this section. Or you want to do the second one? How will you do the second one? Yeah, take out the cosine. Okay, so okay, you want to take out the cosine. Okay, let's take out the cosine of both. 7 integral of x over the x squared plus 1 dx plus 5 integral 1 over x squared plus 1 dx. So what is the antiderivative of the second one? What is the antiderivative of 1 over x squared plus 1?
Arctangent x.
Arctangent x, thank you. That's C, right? And what is the antiderivative of this one? X over x squared plus 1. So we can do what? Substitution. Normal substitution, the chapter 1. So you did like 18 problems of this kind. So let's make u equals x squared plus 1. Du will be 2x dx, right? So when you replace we get integral, you know, and now I can do it faster because you are familiar with this. So we got instead of x squared plus 1, I write u, and instead of x dx, I write 1/2, right? So 1 du over 2. So I take this half outside. I got 7 halves. What is the antiderivative of 1 over u?
ln u.
Ln absolute value of u, right? Plus 5 arctangent x plus c. And now, so now instead of u, what I'm going to write? Ln of absolute value of, what is u? U is
2x plus 1.
x squared plus 1, right? This is u. Then plus 5 arctangent x plus c. And now, notice that the actual value of something positive is positive. So x squared plus 1 is positive because this is this function. So this function is always positive. So I forget about the actual value. So this is just normal. And that's it. Okay, so that's the second example. Okay, so now ready. We're going to do the main plate. So this was warming up. And we were using basically these integrals, trying to use, well, we mainly use this one, right? So integral of 1 plus x squared dx equals arctangent. That's what we use mainly. So now we're going to go over here. That's the main plate. This is really what we want to do, but we'll do a lot tomorrow. I want to start with one. So this is also from wet work. Let me show you. So you guys try to go directly. My advice is finish the class and go and solve this problem. Go to your wet work and start solving your own problem from wet work. And go. the one that I'm gonna solve is, so you see, we solved that one. We solved this one. Now, this one we'll do tomorrow. Tomorrow, we're gonna do this one. As ugly as it can get. So, here we go. So, really good one for the exam, okay? So, example. So, we have to do a square root, integral of 81 dx over x squared square root of x squared plus 25. Okay, so you guys look at this integral. So the actually not the integral. You look the square root, right? That's the ugliest thing. So you go to here. So what we have is the square root of a squared plus 25. So tell me, you're gonna choose 1, 2, or 3. So this is 1, 2, and 3. If you have the square root of x squared plus 25. See? Which one?
Number 2.
Number 2, because that one has positive. A squared plus 25 is the same as 25 plus x squared. So we're going to choose that one. So question, what is A? So let me write it down here. So my ugliest part is this one, x squared plus 25. So question, what is my substitution? X equals what? Basically, my question is, what is A?
Square.
5. 5. A is 5.
5.
So X is 5. What else? Tangent theta. Okay. And it's coming from this table over here. So that's what we're going to do. X equals 5 tangent theta. So we're going to do the substitution. X equals 5 tangent. So when we do this, so let's say this is the first step. So you choose, first step, you choose your substitution. Then you find the x. What is the x? What is the derivative of tangent?
Secant squared.
Secant squared, yes. So this is my first step. Now my second step is substitute. And so we can say first step, choose your substitution. Choose your substitution. Second step, we're gonna do replace and simplify. So replace your value of x and simplify. So let's see how much time I have. Yeah, I think we can do this. So please go ahead and replace it and try to simplify and tell me what do you got. This is very important step because you have to plug in and then use this formula over here. We will write it down over here. So we need to use 1 plus tangent squared equals secant squared theta. We use we have to use, so use was 1 plus tangent squared of theta equals I forgot. 1 plus tangent square theta. Make sure, because I don't want to make mistakes. Here you don't want to test it. Secant squared, yeah. 1 plus tangent squared equals secant squared. If I make a little tiny mistake, it's going to be a headache. So you have to go here in these problems slow. Secant squared. Okay. So you had to substitute and simplify. So let me give you 2 minutes to try to do that by your own. Let's do it together. So to avoid mistakes, I like to do this first. Let's simplify the square root first. So the square root, and I do it apart, and then I evaluate it. So square root of x squared plus 25. So I replace, that will be square root of 25 tangent square of theta plus 25. Yes. And then I factor the 25. So I got a square root, factor the 25, and I get tangent square of theta plus 1. And now, what is tangent square plus 1? What is that? What is this? Tangent square of theta plus 1. So tangent square theta plus 1 is?
Secant square.
Secant square, thank you. This is secant square. Now, we have the dilemma of the square root and the squares. But since I'm taking the theta in the right angle, so I can just forget about the absolute value. Well, let's put the absolute value. 5 secant theta absolute value, but since the angle is in the right place, the angle is because the angle is between minus pi halves and pi halves. Since the angle is between minus pi halves and pi halves, this is just 5 secant theta, as you wanted. Okay. So my square root of a square plus 25 is just 5 secant theta. So now I go back to my problem. I like to do this. At least myself, I make less mistakes. So, so let me, let me write it over here. Just to be, so what do we have? We have that the integral of 81 dx over x squared square root of x squared plus 25. I mean, you don't have to do it this way. I just do it because, you know, I had to, I don't want to make you dizzy moving the screens all the time. So after this, so I will get, instead of a square root of x squared plus 25, I'm getting phi secant of theta. Okay. My other substitution was x is phi tangent theta, dx is phi secant squared d theta. So I forgot here my d theta. So here, don't forget to replace d theta. So you are finding the derivative with respect to theta, then you have to write d theta. So here, instead of dx, I'm gonna write phi secant squared theta d theta. So instead of dx, I'm gonna write phi secant squared theta d theta. And now I have some hope because secant and secant squared, one of them is gonna cancel. So now I have 81, and I have x squared. So, but x, what is x squared? What is x squared, guys? If x is phi tangent of theta, what is x squared?
25 tangent square.
Tangent squared, correct. Thank you. I tried to ask questions. Some are easy, some are difficult, but I want you to interact. So now we got this phi cancel with this phi, this secant cancel with this square, and then we got 18 over 25. So let's start making this nicer. So we will get 81 over 25, and then we get 1 secant over tangent square of theta d theta. Okay. Now, there are two ways to do this. Probably just easier to that. Okay, let me do it this way. So let's say that we want to use the formulas, right? So this is secant theta over tangent square of theta. So there is a way that I can manipulate this because I got 1 over cosine, and then we have, let me put it like this. You have 81 over 25, and then secant is 1 over cosine. So you have 1 over cosine, and over here you have tangent. Tangent is sine square of theta over cosine square of theta d theta, right? So you cancel this cosine with this cosine, so you got the following. You got 81 over 25 integral cosine of theta over sine square of theta d theta. Okay, so now we need to make this look similar to some integrals that we have. So if I do the following, but this is not the only way. There is another way to find this integral. But let's say I choose to do it this way. If we have time, I'll do it the other way. Direct way. In case you don't have table, but since you have table, so you can write this as cosecant of theta times cotangent of theta. right? Because you have cosine and two sines. So you can write this as and sine, right? So times 1. So this guy is cotangent and this guy is cosecant. So if you go back to the formulas I put at the beginning, so you'll see that integral. Where is it? Oh, cosecant times cotangent, right? This one. Cosecant times cotangent. So the antiderivative of that is minus cosecant. And that integral is not difficult to do, but I just doing it just to see if you can save some time with that table. So we are getting 81 over 25, and then minus cosecant, minus cosecant of theta. Okay, but we are not done. Okay, so here's the so far this all this is kind of similar what we had been doing. Okay, we did a so we have this the square root of a squared plus 25. We look the table, we choose 5 tangent of theta, we replace it over here and then start simplifying. And once we simplify, we use the table and then we got an answer. Well, so that's why this problem is a little bit harder than the other one. So now, turns out that our problem is in terms of x, not so we need an answer in terms of x, not in terms of theta. So we need to do some trigonometry at the end. So our substitution was the following. So here you have to pay attention, please. So you do x equals find tangent of theta, right? Therefore, x over 5 is tangent of theta. Okay. Therefore, there is a triangle related to this. There's a triangle, and then this is theta. So the opposite, so sine theta is opposite over adjacent. Remember? That's also in the formulas for the exam. So it's opposite over adjacent. So we need to find the hypotenuse because we need to find cosine of theta. Okay. Or if you want, cosine of theta is also 1 over sine of theta. Okay. So we need to find sine of theta. So to find sine of theta, we need to complete this triangle. So if this is 5 and this is x, what is the hypotenuse? You guys tell me. You have to use Pythagoras theorem. So by Pythagoras theorem, what is the hypotenuse? So C equals, what is that?
Square root of x squared plus 5 squared.
Right, but then, so yeah, so it will be c squared equals a squared plus 25 by Pythagoras theorem. But since I need c, that will be the square root. Square root of x squared plus 25. So now we're done. So this is going to be sine of theta. Sine of theta is what? Opposite over hypotenuse. So that will be my, okay, so I forget my plus c. Now, this sine of theta is plus c. And then This is minus 81 over 25, 1 over sine of theta. And then sine of theta is opposite, x over the square root. So it's going to be x over a square root of n squared plus 25 plus c. And if I solve it, I mean, I put simplify better, I'll get minus 81 over 25, then the square root of x squared plus 25 over x plus c. And that's my final answer. Okay, so let's check in wet work. So let's check our answer in wet work. We're gonna get this one. So we got correct answer. So it's x times x is a square, right? So 81 over 25, x times square root of x squared 25 plus 25 divided by x. And that's what we got over here. So we're gonna do more tomorrow. And then you'll get almost 15 points by sure in your exam.
Sir, for the answer, why would you I guess like switch the square root x squared plus 25 over x? Why would you switch that?
Because it's not simplified. I don't like to see it like you never write an answer like let's say you have x over 5/3, right? You usually don't write the answer like that. You write it 3/5 of x, right?
Okay.
So that's what I'm doing.
Okay.
But Wedwork will understand. Oh, sorry. Wedwork will understand it. Okay, so please be respectful with the chat and make over here from Diego Rivera. So he sent us a message saying you can ask for tutoring online. Just be kind and send the PDF before or the question before. You know, those problems are not easy. They might, if you just show up with the problem, they might struggle. But you know, these problems are not that easy. So send them the problems before in advance if you can. And that will make their life easier and probably they will explain you better. And yeah, I think that's it. Let me see more questions. Well work. The quiz this week is on Wedwork. So this week is not on for everybody. Okay, this quiz is in Wedwork. On the 14th, the quiz due on the 14th. Yes, that's, somebody's asking. So yes, the quiz due on the 14th. Okay, no more questions. So follow my advice. You wanna catch this? You wanna try to understand this? Go to Wedwork and solve this problem. Your problem might be instead of 25, have 36 or something like that. 49, something like that. So that will be very useful. Okay, guys, I'll let you go.
Third question.
Uh-huh.
How would you make an appointment in the math center?
Say again?
How would you make an appointment to like schedule so they can help you like answer the questions or explain?
With me or with the learning center, you follow here this message that I sent over here. They explain to you how to do it.
Okay.
So you just follow and they will tell you what to do.
Okay.
Or I'm 4:30 to 6 today. Okay?
Okay.
Okay.
Bye.
Bye. Okay, guys, so I'm gonna let you go.